Hey everybody, this is Mr. Ainsworth, and we are going to get into a new lesson here. Chapter 5, Section 6 in your new Algebra 1 textbook here about parallel and perpendicular lines. Okay, we have two goals. All right, two goals. Not very, not very much. Determine the relationship between the parallel, all right, and perpendicular lines. All right, so what's the relationship between two parallel lines? What's the relationship between two perpendicular lines? All right, so we got two big concepts here. All right, parallel and perpendicular. And in that, or underneath that, or within that, all right, we want to find the equation of the line given the slope of the line under certain conditions. Okay, but first we need to discover the relationship between either parallel or perpendicular lines. So let's first talk about parallel lines. Okay, so these lines that you see here in either graph 1 or graph 2 are parallel, but what's the relationship? What do they have in common? All right, and that's what we want to do first is we want to determine that. All right, so let's do a little labeling here so we can take a look at the lines individually. This is A, and this is point B. So point A is here, point B, and we'll call this line 1. This is line 2. We got point D and C, excuse me, C and D. And over here in graph 2, well, we have line 3 and we have line 4, right? Okay, and we're just going alphabetically here, E, F, all right, and G and H. All right, so let's talk about graph A first, and then we'll talk about graph B second. Okay. Okay. So now, what's the relationship between the two? So what we want to do is take a look at their slopes of their lines. Okay, their slopes, and we know that the definition of slope from prior lessons is equal to rise divided by the run. Okay, we're talking about the vertical change. All right, divided by the horizontal change. Okay. What is that? I mean, we can do it we can do the algebraic way too. We can do y2 minus y1 divided by x2 minus x1. We could do that. However, uh, rise over runs easier on a graph. So what we're going to do is we're going to analyze the slope from A to B. Everybody say A to B. A to B. Okay, so we're going to rise. The question is, how far do we rise? And if you count 1, 2, there's 2 units up. And if you count to the right, 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. Okay, there's 5 units to the right. All right, so the slope of this line, we'll call it M1, is up to right 5, rise over run, 2/5. All right, what's the slope from C to D? I don't know. Let's figure it out. So we go rise 2, run 1, 2, 3, 4, 5. So we run to the 5 right. All right, notice there up is positive, right is positive. So the slope of M stands for slope, by the way. All right, coming from the French word monter. All right, M equals monter, which is a French word meaning to climb. The French figured it out with Rene Descartes, by the way, back a long time ago. So they don't use S for slope, which kind of makes sense for us since we speak English. However, the French figured it out and they used M for monter. So we use M for slope. So we go up to right 5. And notice, oh my God, they're the same slope. The question is, does that happen all the time with parallel lines? I mean, L1 is parallel to L2, and notice right here, their slopes are the same. All right, same slope. Does that happen all the time? What happens if you have, a downward turn? They go to the lower right. They have negative slope. But are they still the same? Well, let's find out. So I give you the fact that they're parallel in the beginning. So let's figure this out. So here we go. We're gonna go from E to F. Okay, we're gonna run to the right, and we're gonna go down. Question is how far. So we go from E 1, 2, 3, 4, 5. So that's positive 5 to the right. Down 1, 2, 3, 4. That's a negative 4. All right, so right now I see the slope of this line, L3, is a negative 4/5. So M3 is negative 4/5. The slope of the second line, or line 4, okay, how do you get from G to H? Well, you got to go to the right and you got to go down. Notice the arrows, notice the direction. All right, you got to go to the right. How far? So 1, 2, 3, 4, 5. That's 5 to the right. That's positive. Down 1, 2, 3, 4. Down 4. Holy cow, look at that. All right, the slope of the fourth line, M4, is negative 4/5 again. Holy cow, look at that. They're the same slope again. Guess what, my friends? Okay, the relationship between two parallel lines is that they have the same slope. Okay, parallel lines have the same slope. Okay, that's same. Underline that word, equal. Okay, I'm talking equal slope. Okay, and that's to ensure that they go in the same direction. If they have different slopes, they would intersect and they wouldn't be parallel. That's relationship number one. All right, so let's discover relationship number two. All right, so what's going on with these perpendicular lines? All right, so these are given to be perpendicular. So L1, L2, L3, and L4. Let's figure out the slopes. Okay, so on this graph, let's label A, B, C, D, E, F, G, H. So we can talk about them. Okay, so what's the slope from A to B? So we got to go up and right. You just count. So up 2, right 1, 2, 3, 4, 5, 6. Right 6. So the first slope, M1, is 2/6, rise over run. So M1 is equal to 1/3. Always reduce your slope, okay? Or simplify your slope. What's the slope of, oh, that was L2. Okay, whatever. All right, slope of the blue line, okay? How do you get from C to D? Well, you got to go right 2. All right, ooh, down, let me see, 1, 2, 3, 4, 5, 6, down 6. All right, so my second slope, got these backwards, but who cares? All right, is negative 6 divided by 2. So negative 6 divided by 2, that's usually negative 3, especially on Fridays. Thank God it's Friday. Okay, so question is, what's the relationship here between negative 3 and 1? Holy smoke. All right, what's the relationship? Well, first of all, 1/3 is positive and the other one's negative, so they're opposites. Okay, so they're opposites. And 1/3 is the reciprocal of 3. So they're opposite reciprocals, okay? Or some teachers say negative reciprocals. Okay, however you want to say it, it doesn't matter. Either negative reciprocals or opposite reciprocals. The question is, does that happen all the time? Okay, so let's figure that out. All right, so from E to F, we can go either right and down or down and right. It doesn't really matter. So down and right. So down 2, negative, right 2. So here my third slope is negative 2 divided by 2, that's a 2, or negative 1. If you went right and down, it'd be right 2 is positive, down 2 is negative, right? Same thing. Now G at G to H, you got to go up 2 and right 2. So here, the slope of the fourth line, or M4, is 2 divided by 2, or 1. So the question is what's the relationship between 1 and negative 1? Well, guess what? They're opposites, and one's a reciprocal of one automatically, so these are opposite reciprocals too. Holy cow, it happened again. It turns out, guys, it's very simple, that the slopes of perpendicular lines are opposite reciprocals. Slopes of perpendicular lines are opposite, all right, reciprocals. All right, opposite reciprocals for perpendicular lines. By the way, the symbol for perpendicular is the upside down capital T. So L3 here is perpendicular to L4. And over here, L1 is perpendicular to L2. Okay, so perpendicular is the upside down capital T. All right, so let's take these main ideas here and let's apply them, okay? And let's go for it here. In the first one here, this example 3 here, we're given some quadrilaterals, okay? A and B. And the question is, a quadrilateral with both pairs, okay, that's an important word, of opposite sides parallel is a parallelogram. If the opposite sides are parallel, we have a parallelogram. If opposite sides are not parallel, then you don't have a parallelogram, okay? The word parallelogram comes from the word parallel. Okay, you have both pairs. We're talking two pairs because every quadrilateral has four sides, right? So is PQ here, PQ, let me highlight that. Okay, PQ, is that opposite? Well, first of all, it's opposite of SR. Are they parallel? Well, let's figure it out, okay? Let's go from P to Q. Let's go right 4, all right, down 2. So that slope, the slope of PQ, is equal to negative 2 fourths, all right, or negative 1/2. The slope from Q to R is, well, excuse me, I'll do that later. The slope from S to R, you got to go down to right 4. So negative, oh my gosh, it's the same thing. So the slope of SR here is equal to negative 2 fourths or 1, negative 1/2. They're the same. So these are parallel, and we use this arrow symbol to symbolize that. So already right here, I have a one pair, but I need both, right? I need both, and both means we got two pairs, two. Okay, so now what we want to do is take a look at the other pair of sides. We're gonna from P to S, what's going on here? So we can go left and up. All right, to S. Oh, that's S to P. Okay, it really doesn't matter. If you can go P to S, you can go to S to P, right? So you're going to go left 2, up 3. So the slope of P to S, excuse me, S to P, is equal to negative 3 halves. 3 divided by negative 2 is negative 3 halves. It's negative slope, right? Well, how does that compare to Q to R? So we got to go right 2 and down 3. Well, the slope from Q to R is equal to negative 3 halves. Oh my God, they're the same, so they are parallel. So double up on the arrows, okay? The reason why is because this is the second pair of parallel lines and they're different than the first pair in red, right? So we have both pairs of opposite sides parallel. So we're going to say, yes, this is a parallelogram, okay? Let's do the same thing over here. We got J to M. Okay, let's figure out this one here. Is this side parallel to this side? I don't know. So we're going to go down 1, 2, 3, 4. Right 1. So the slope from J to M, slope from J to M is equal to negative 4 divided by 1, which on Fridays is negative 4. Okay? Now from K to L, I can go right and down. So I go right 2, down 1, 2, 3, 4, down 4. So the slope from K to L, all right, is equal to, it's from K to L, just writing a little bit better there, is negative 4 divided by 2 or negative 2, and they're different. So these are not parallel. All right, so JM is not parallel. Put a slash through the parallel symbol to KL. So I can already tell that this is not a parallelogram. All right, even if JKL was parallel to ML, which it's not, okay, you can check that. I mean, this is up 1 and then right 1, 2, 3, 4, 5, up 1. So it's 1/5. This one is 1, 2, 3, 4, 5, 6. So right 6, up 1. So this is 1/6. So here the slope is 1/6, and here the slope is 1/5, and obviously they're not the same either. So we don't have a parallelogram here. It's just a quad. All right, it's just a quad. That's it. Nothing special about it. It's just a four-sided figure, guys. Okay. All right. Now let's move on. Let's do something crazy. All right. Now on this one, check this out. We got to find the equation that is parallel. That means the same slope, so underline that. Always take a look and analyze the keywords in any problem, okay? If it says parallel to something, you got to be thinking same slope. If it says perpendicular, like on the next problem, you're thinking something different. On this one here, it says parallel, so it means same slope. So it's parallel to 2/3 x minus 2. So I can see the slope here and the y-intercept here. And it's got to go through this point here, 1 comma 2. So let's plot it. 1 comma 2 is right here. Let's plot this line. Let's graph -2, and let's go up to right 3. So up to 1, 2, 1, 2, 3 to the right. Up to 1, 2, 3 to the right. And let's graph. Okay, so there we go. So this is y is equal to 2/3 x minus 2. And here's the point. And we want to find the equation of the line that passes through this that's parallel to this one. So it's got to be, I don't know about you, but it's got to be somewhere around in there, right? So what in the world, what's the equation of that line? All right? What's the equation of that line? So let's figure it out. So y minus y1 is equal to m times x minus x1. This right here is called point slope form. We always use it, all right, when you want to find the equation of a line. All right, we need to know a point, which is x1, y1, which is right here, by the way. So the x1 is 1, y1 is 2. And you want to take that, and you want to take the slope of it, the slope of this line, and substitute in here. We want to use the slope of 2/3 because we want it parallel. So we're going to use that. So right here is the slope. All right, so here we go. Y minus the y coordinate, which is 2, is equal to the slope of 2/3. It has to have the same slope of the line that's given to us. All right. Okay, we see it right here. It's up to right 3, slope of 2/3. All right, there's my slope. And it's times x minus the x coordinate of 1. So what is this equation? Well, let's solve for y. All right, we got to distribute. Always distribute. Two-thirds times x is 2/3 x. 2/3 times 1 is 2/3. We always add the opposite of what we see. So we have y is equal to 2/3 x. Let me see, 2/3, excuse me, 2, negative 2/3 plus 2 is 2 minus 2/3, which is under 2. So think pizza. We have 2 whole pizzas. From one of them, all right, you divide it up into thirds and you take away 2 parts out of 3. So you eat this piece and you eat this piece. Well, you have 1 and 1/3 or 1 slice remaining. That's 1 out of 3, right? So it's 1 and 1/3. So we have 1 and 1/3. There's your slope and there's your y-intercept. And so what we want to do is take a look at this line. Notice it has the same slope, but does it go through 1, 2? Well, let's find out. So let's graph. Okay, so let's graph 1 and 1/3. So here's 1, there's 1, there's 2. So divide it up into 3 equal parts. That's 1 and 1/3, 1 and 2/3, 2. So 1 and 1/3 is right here, right about there. All right, and then you got to do the same thing here. So we want to rise 1. So up 1, right here, up right 2, 1, 2, excuse me, rise 2. I didn't say that correctly. Okay, so we got to go up 2. So up 1 and then 2. So up 1 unit, 2 units, 1, 2, 3. Here we go. Come on. So then you graph. There we go. All right. So it goes through the point right here, which is what we wanted to make happen. We had to make it go through 1, 2. It has the same slope and they're parallel. All right. So we got line 1. This right here is line 2. So this is line 2. This is line 1, and line 1 is parallel to line 2. All right, remember that's the parallel symbol, the vertical lines, right? All right, and that's what it was all about. Now, on the next one here, we switch to perpendicular. And by the way, that reminds me, this is a video, right? So if you didn't understand something, then you have the ability to go back in time, right? Just pause it, rewind it, and review it. Listen to it and go at your own pace. It's a video. Pause and play, right? Pause and play. Use the video effectively. All right, so now uh, we want to find the equation that's perpendicular to this. Well, let's go back to the very beginning. All right, we found out right here that the slopes of perpendicular lines are opposite reciprocals. So let's use it. So the question is, what is the opposite reciprocal slope of this? Here the slope is negative 3/4. I don't want that. I want to know the opposite reciprocal slope. What's that? We're going to call that perpendicular slope. All right. Well, the opposite of a negative is a positive, and the reciprocal of 3/4 is 4/3. So there we go. The opposite reciprocal of negative 3/4 is 4/3. We want to use this slope, and we want to use this point right here, x1 comma y1. So we're going to use x1 comma y1. I don't want to write like that. I want to use 0 comma 3, which is x1 comma y1. So we have y minus y1 is equal to m times x minus x1. That's called point slope form again, right? Just recall, look what we did it right here. So let's use it. All right, point slope form. And we want to substitute a point and the slope in. So let's do it. Y minus 3 is equal to 4/3 times x minus the 0. All right, the x coordinate. Now x minus 0 is just x, and 4/3 times x is just 4/3 x. All right, let's add the opposite and let's solve for y. Oh, we always do that, right? So add the opposite. And what do you get? Well, okay, you get y is equal to 4/3 x plus 3, where that's the slope and that's the y-intercept. Okay, so let's graph and let's figure out what's going on. All right, so we're given this equation and the point. So let's graph the given equation. Okay, we'll call this line 1. So it's up there at 3. We do go down 3, right 4, and we plot the line. There we go. All right, it's got to go through 0, 3, which is right here. There's 0, 3. So where's our perpendicular line? So here 3. So it's got to go up 4, right 3. From 3. So we got to go up 4, 1, 2, 3, 4, right 1, 2, 3. You could do that. Or you can reverse it, make them both negative, and go down 4, right, left 3. 1, 2, 3, 4, 1, 2, 3. So let's graph that line. Whoop, didn't draw it very well. There we go. All right. And notice there's a right angle in there. All right, it's not perfect, but it's close enough for government work. Let me see, down 4 right there. Yeah, I counted right. So there you go. All right, so this is our new line right here. This is L1 and this is L2, and L1 is perpendicular to L2. Okay? Remember that this symbol right here, that means perpendicular. Okay? And that's how the game is played, my friends. Now remember, this is a video, right? And that's why I produce these things, is that you have the ability to go at your own pace, number one. You have the ability to pause and play and rewind and practice. All right, if you didn't get the first time, then listen to it again. Do whatever it takes. And obviously, the next step is, oh my God, you got to do your homework. Okay, so here we go. Do your homework. Yes, that's important. Okay, do your homework and do it in your spiral. Do your work. Oh, gotta spell this right. In your spiral. Okay, and make yourself proud. And if you need to, of course, go back to the beginning. Listen to it. And I'll see you in my next lesson. This is Ainsworth. I'm signing off. I'm out of here. I'll see you in my next lesson. Bye bye.